Hello everyone, myself Dr. Santavi Kundu. I welcome you all to this lecture of soft computing techniques. This is the fifth lecture of module 6. So, in this module, we are solving numerical examples. We are solving numerical questions by using genetic algorithms. Today, we want to solve one question which is maximize fx equal to. We want to solve one question that is maximize fx equal to sine of pi x. X belongs to from 0 to 1. We consider 6-bit string to represent the solutions. So the 6-bit means there will be 0, it can be written as 6 zeros, and 1 can be written as 6 1. So our initial populations can be anything from this to that, from 0 0 0 0 0 0 to 6 ones, any value. So how to convert it now decimal? So we know the formula that decimal equivalent x equal to a plus b minus a by 2 to the power n minus 1 into the equivalent value in binary. So here x can be written as 0 plus 1 by 2 to the power 6, 64 minus 1, 63. So that can be written as x by 63, whatever value we have. So let's try to find some initial solutions. So here we assume the binary strings, which is 100 101. So it is decimal value, that is dv is 37. So now corresponding x, as I said, that x will be equal to that a plus b minus a to the power n minus 1 into the decimal value. So here x is 0 plus b minus is 1, 63 into the value 37. So that is 37 by 63. So that is equal to 0.587. So that is the value of x. Now what is f of x? So f of x you can write sine of pi into 0.587. So whatever value we have, that is 0.96. So that is fitness value also 0.96. Similarly, the value of second chromosome is 001100. So equivalent decimal value is 12. So here x will be equal to, similarly for this value, the x can be written as x equal to 0 plus 12 by 63. So that is basically 0.19. So f of x is 0.56, fitness is 0.56. So similarly, third chromosome is 1111010, so that is equivalent to 58. So is the value is 0.921, f is 0.25, so fitness value is 0.25. 4 is 101110046, x is 0.73, value is 0.75. So expected count, you know the expected count is fitness by average. So the expected count is equal to fitness by average. So by doing the calculation, we will get it 1.53. The expected fitness for this is 0.89. Here it is 0.39. That is 1.19. So as 0.39 is minimum, so we count actual count. We are taking 0. This is maximum. We're taking 2 times, and these are 1 time. So it does means that. So it means that chromosome 1 is selected for 2 times, chromosome 2 is selected for 1 time, chromosome 4 is selected for 1 time, and chromosome 3 is not selected. Okay, so next is that we select the chromosome, that is basically the chromosome. We select the chromosome 1, which is 1 0 0 1 0 1 two times. So select the chromosome for 2 times. We select chromosome 2 for 0 0 1 1 0 0. So chromosome 2 selected for that, and chromosome 4 is that. So now, so we have done the initial populations, then we find the fittest and we select as parents. We select chromosome as parents. So next is that crossover, and next then it is mutation. So now it is crossover, single point crossover. Crossover point was like 3. So here the crossover point is 3. So here this offspring will be 1 0 0 1 0 0. Here the offspring is 0 0 1 1 0 1. Here is crossover point is 2. So here it will be 1 0 1 1 1 0. It is 1 0. Then it will be 1 1 1 0. This is 1 0 0 1 0 1. So that is offspring. So similarly, the decimal value, that is same as the before. So that is x equal to a plus b minus a to the power n minus 1 into the decimal value. So that is x equal to 0 plus 1 by 63 into 36. So you'll get is 0.57. F is 0.97. Similarly, here is similar to 13, like that 8 plus 4 plus 1 13. X is similarly 0.21. Fx is 0.60. Here the decimal value is 46, so x is 0.73, fx is this. So this is the before mutation. Now next step is mutation. So we have these chromosomes, this offspring before mutation 1 0 0 1 0 0 0 0 1 1 0 1 1 0 1 1 1 0 1 0 0 1 0 0 1. So here we are doing flipping mutation here. So this will become 0. So 1 0 0 0 0. That is 1 0 1 1 0 1. That is 1 0 0 1 1 0. This is 1 0 1 1 0 1. So x is 0.51. So the f value you can write, it is something like 1.00. Here this is 0.78. Previously it was maximum these things, now it is maximum 1. So after mutation we are getting the maximum value of fx equal to sine of pi x. So you know that is pi by 2. So at near half we will get the value of 1. So this is the example. So now questions here, you try to guess, you try to find the mutation probability. Find the mutation probability for these questions. For these questions, I hope you can find the mutation probability. Now next question is a supply chain problem. So condition is that demand of each customer zone is satisfied exactly by one person. Each person supplies to exactly one customer zone. So if person 1 goes to customer 1, so distance is 20. For customer 2, distance is 25. For 3, distance is 17. For 4, distance is 22. For person 2, if person 2 goes to customer 1, distance is 14. Then for 2, 9. For 3, 19. For 4, it is 6. For 3, it is 13. For 2, it is 15. For 3, it is 23. For 4, it is 30. Similarly, if person 4 goes to customer 1, so that is 8 distance. For person 4 goes to customer 2, distance is 25. For 3, distance is 12. For 4, distance is 7. So objective is that to minimize the travel distance d. So if you need to find the minimum value of d, we will try to find the maximum value of 100, suppose 100 minus d. use summation, it will never be 100. So maximum is 100 minus d. So if maximum value 100 minus d, so automatically we will find the minimum value of d. So that things you want to do it. So there is some crossover procedure is defined here. Suppose crossover procedure for P1 is A, B, C, D, and P2 is I, J, K, L. So offspring 1 will come from P2. So we write it, interchange these two. So L and so L, J, K, I. And for offspring 2, interchange D and A. So it is D, B, C, A. So that is the crossword technique. Now random number used for crossover. So here crossover probability is 0.8. So for the first iteration, random number is 0.98, for 1, for 2 0.93, for 3 it is 0.45, for 4 it is 0.57 for the first iteration. For the second iteration, the crossover probability uh, for the second iteration, crossover probability is 0.8, but random number is 0.47, 0.55, 0.88, 0.93. So what does it means? That if the crossover probability, suppose you are choosing a random number k, if rk is less than the crossover probability, then we will select the k for crossover. So here the crossover for the first chromosome is 0.98, greater than that, so it will not be selected. This will not be selected. Chromosome 2 will also not be selected. So chromosome 3 and 4 will be selected as the crossover probability is less than the uh, as a random number less than the crossover probability. So chromosome 3 and 4 is selected in the first iterations. So 3 and 4 selected, select as parent in first iterations. Reason is that the random number is less than the crossover probability. In the second iteration, the crossover probability is 0.8, random number is 0.47, so chromosome 1 is selected. So in the second iteration, chromosome 1 and 2 are selected as parents as their random number is less than the crossover probability. Here 3 and 4 are not selected. Okay, so this is the question. Now we are going to solve it. So we are assuming any initial populations. So chromosome 1, 2, 3, 4. So for chromosome 1, details is that 1, 2, 3, 4. So customer 1 first, then 2, then 3, then 4. So if you want to solve this question, so from 1 to 2, then the person goes to from 1 to 2 to 3, 3 to 4. So distance is 20 plus 9 plus 23 plus 7. So it is 59, 100 minus d is 41. So that is the minimum value we want to maximize it. Similarly for the second chromosome, 2 to 4 to 1 to 3. So that is 86. 3 to 1, 4 to 2. So that is 56. So 100 minus that 44. 4 to 3 to 1, so that is 64. 100 minus is that this thing. So now find the average of these things. So if you find the average number, so you will get the average number as, to add this you will get the average number as 33. So expected count, you know, that is fitness value by average. Fitness by average is known as the expected count. So our expected count will be 41 by 33.75, that is 1.21. So write it 1. So 14 by that, so 0.41. So expected count here is 1.30. So this is the maximum. So writing is 2 and remaining these are 1. So chromosome 2 is not selected. So here you can write that chromosome chromosome 3 is selected for 2 times, and chromosome 1 is selected for 1. So chromosome 1 and 4 are selected for one time, and chromosome 2 not selected. So chromosome 2 is not selected because it's the minimum value. Chromosome 2 is not selected. Okay, so now you can write it that for mating pool, for the next selection is over. Now this is for the crossover. So for the crossover, uh, we write the string, so that this is the chromosome 1. You can write 1 2 3 4. So here chromosome 1, then 2 2 and 4. So chromosome 1, then 2, then 4, 2 2, then 4. So write it in new chromosome 1, new chromosome 2, new chromosome 3, new chromosome 4. Okay, so as I say, the here chromosome 1 and 2 will not participate in the crossover. Chromosome 1 and 2 are not participated in the crossover procedure, as their random number is more than the crossover probability. It's not participated in crossover procedure. So here 3 and 4 will do the crossover. So 3 is 3 1 4 2, 4 is 4 3 2 1. So by the crossover you will get it. This will change. So this will change. So 1 4 3 2 offspring 1. This will change. So 2 3 2 and 3 interchange. So we'll get 2 1 4 3. So that is offspring 2. So there will be 4 chromosomes. One is P1 P2, then O1 O2. So chromosome 1 2 and O1 O2. So in the next iteration, so that iteration, first iteration completed. Now the next iterations, as had the first iteration is completed, so that is the iteration 2. So 2 chromosome 1 2 and then 3 4. So objective function is 59, fitness value is 41, so average value is 35.75. Similarly, the expected count is the fitness by average, so that you will get it 1. This is 1.03, 1.23, 0.53. As it's the minimum value, so write it 0. Maximum is 2, so 1 and 1. So in the second iterations, chromosome 2 selected for 2 times, then chromosome 1 selected for 1 time, chromosome 3 selected for 1 time. So here these two will participate in the crossover procedure. So next iterations will have these things 2 1 4 3 4 2 3 1 and these two. So the fitness value is D is 81, 100 is 19. Then then for the chromosome 2 distance is 62, 100 minus is 38. So like that. So again average value is 35. So this is minimum counted 0, this is maximum counted 2 times 1 1. So here chromosome 3 counted 2 times, so chromosome 2 then 3 then 3 then 4 is selected. So it will go again the crossover procedure. So again do the crossover procedures, again do the next iterations. So in this way you can proceed to get the best optimal solution. So this is the way how genetic algorithm is working. So these are the concept. I hope you have understood these questions. Now we try to understand one knapsack problem. So you know that what is knapsack problem. The weight is maximum weight is 12 kg, and you need to find the maximum value. So the item is A, B, C, D, 5, 3, 7, 2, weight. Price is 12, 5, 10, 7. Here is the weight is 12, so chromosome 1, so that is 0, 1, 0, 0. So here we can write it, the weight is uh, B and C selected, so it is 10, price is 15. Now here the B and D is selected, so weight is 5, value is 12. Here the 1101, so A, C, D, so A is 5, then C, A, B is 3, then C not selected, D selected, so that is weight is 10. So value is 24, 12 plus 5 plus 7, the value is 24, and this is not a feasible solution because weight is greater than 17, so it will not participate in the calculations. So now you need to find the average value, so you know the value of that, so an expected count we'll try to find. So here the average value is that 15 by this 15 plus 24 plus 12, so you can write like that, 15 plus 12 plus 24, so that is by 4, not qualified, so write it by 4, so you can write it 51 by 4. So in this way, if you find the expected count for the maximum, we write it 2 times, expected count rest is 1 1, and this is not qualified, so you can write it this not qualified, so this is not qualified, chromosome 4 is not qualified. So in the next iterations, you will solve chromosome 1. We will solve chromosome 1 for single time. So that is 0, 1, 1, 0. Chromosome 2 is selected. So chromosome 3 is selected for 2 times. So we are writing it chromosome 1, 1, 0, 1. Next also 1, 1, 0, 1. And then you can write it 0 1 0 1. So we are writing the next iteration. So here this is the thing, 1 1 0 1 selected for 2 times, this is selected for 1 times, this is selected for 1 time. Now do the crossover, so we'll do the here we apply the crossover, so that is the generation 2. So in this way you can continue it. So this is the example of knapsack problems. Now you are trying to solving one traveling salesman problem. So you know the traveling, in the application of traveling salesman problem with genetic algorithm, with the initial population was created, codification in the form of permutation was used. You know that this. So this is one chromosome 1284. In this method of natural selections, sorting selection was applied. At this method, according to the fitness values, individuals in the population are sorted in ascending order. In this order, the sequence number is given to each individual, and according to this number, random selection is applied. As the method of crossover for foundation encoding, single point crossover use. According to this method, we first crossover point is that. Then we'll do other crossover technique. So here we can use the partial map crossover, order crossover, cycle crossover, etc. We can use here. So just one example of this thing. So this is the chromosome 1, this is the chromosome 2. So here we are writing 1, 2, 8, 5, 4. So we are writing directly, and then 1, 2, 8, 4, 5. So remaining chromosome we are writing in order 3, 6, 9, 7. So this is chromosome 1. For the case of mutation, we just interchange it 7, 8. So after mutation, we'll get. So whenever there is a traveling salesman problem, we can do this type of things, crossover, mutation, etc. So you can select the best thing, then crossover, then mutations, and it will continue next iterations like that. So here, try to understand one questions. Question is that these are the 5 cities A, B, C, D, E. So from A to A, no. From A to B, 2. From A to C, 5. From A to D, 7. From A to E is 1. Similarly, from B to A is 6. B to B not this is not defined. So B to C 3. B to D is 8. Similarly, B to E is 2, C to A 8, C to B 7, C to C not defined. Like that, this is a travel session problem. So we want to solve this question by using the genetic algorithm. So for that, you can assume any initial solutions. So first is A to E to C to D. So then B to A, so that is 17. Then from A to B, E to C, D to A, 22. Then A to C, D to E to B to A is 23. Then A to B, D, C, E, A, 24. Similarly, you calculate these things, so 25. Now you can write the top 5 solutions. So top 5 is the one to minimum value. So minimum is, this is 117. So then 22, then 23, then 24. So then you can write also 25. So if I say initial 4 solutions, so let's having 4 solutions. So according to the fitness criteria, we are sorting the to four values. So this chromosome A to E to C to D to B to A, this A to B to E to C to D to A, then A to C to D to E to B to A, then A to B to D to C to E to A. So suppose this is parent 1, this is parent 2, this is parent 3, this is parent 4. So now we need to do some crossover. Again you need to do some mutations. So create 9 populations from crossover mutation. You can also apply elitism. 9 chromosomes, 9 chromosomes, and do the next steps. So after similarly crossover the minimum value. So you try to complete these questions. So in conclusion, so we have solved using genetic algorithm. So we solve numbers of numericals questions by GA. So you try to understand the procedure, try to understand the applications of GA. So question is that, suppose you want to maximize some question, like question is that by using genetic algorithms, find the maximum value of fxy equal to x square plus 2 by y minus xy, where x belongs to 0 to 15 and y belongs to 0 to 31. Okay. So solve these questions up to 3 iterations. Okay. So these are the references of today's class. Thank you.